Yeah, so just keep that in mind. I don't have a microphone yet. I have no voice.
Record it because they recorded it once already.
Maybe. Right, but they have to turn the mic on.
Oh, we need to do it. That's just 10:30. The next one starts, and they have to switch out everything.
Right.
Okay.
Oh, that's true. So maybe like 10:20, I would think at the latest.
Okay.
It was. Oh, hi. Okay. Good morning, everyone. My name's Anna. I'm a meteorologist at News Center 1 in Rapid City. I do mornings, and I'm to kind of introduce everyone. So first we have Susan Sanders. She's a warning coordination meteorologist at the National Weather Service. We also have Bob Riggio. He's our chief meteorologist, emeritus, I think is the title. And he was actually here on the night of the 1972 flood. We also have Alexa White with emergency management. And she provides a lot of the information for sending out all of those alerts and everything like that. And finally, Melissa Smith, a hydrologist with the National Weather Service. So it's kicking us off. Bob's starting it.
I'm going to try to be a little quicker than I was in the last session. We went long. I guess over here went long as well, right? So I don't feel so bad. I don't feel so bad at all. All right. I'm going to talk the meteorology on that day. And I've been involved in weather for over 50 years, and I've never seen the ingredients come together since 1972, like what happened on June 9th, 1972. So it was an historic event, and I can't underline that enough. It was an historic event here in the Rapid City area. You need three things for it to rain. You need moisture, you need instability, and you need a trigger. You need something to kick it off. And we had a abundance of moisture on that day, incredible amount, historic amount of moisture streaming in from the east and southeast into the Black Hills. And when I'm talking moisture, I'm going to talk dew point. This green line right here, this is the morning sounding on June 9th, and the green line is dew point, the red line is temperature. This is height, the y-axis is height, and the x-axis is temperature. So the further away the dew point is from the temperature, the drier the atmosphere. So on the morning of June 9th, you can see it was our atmosphere overhead was rather dry, except for the low levels. I think you can see where the green line and red line meet. I think we had a little bit of a misty morning, a little bit of a foggy morning. But once the sun came up and dried things out, all that went away rather quickly. So we had a dry atmosphere on the morning of June 9th, 1972. This is upstream. This is Huron. This is the same time, 6 a.m. In the morning. This is the Huron sounding, and look how close the green line is now to the red line. So Huron had historic precipitable water after they analyzed this after the fact. They've never seen this amount of precipitable water in the atmosphere. And that was upstream from us. And the low-level jet, which brings in the wind, which are the winds from 10,000 feet to the surface, was out of the east and southeast. So they were coming out of the Huron area as well as out of Nebraska. So this moisture area not only included central South Dakota, but also included down in Nebraska. And the low-level jet was, in some cases, 76 miles per hour. Never seen low-level jet that strong before. 76 miles per hour. One pieball observation recorded at 76 miles per hour. And this is the sounding now at 6 p.m. June 9th here in Rapid City. You can see how close the dew point is to the temperature. Our atmosphere is now saturated with moisture. So we have a plethora. Is that a good word? Plethora. A lot of moisture, folks. That's what I'm trying to say. A plethora of moisture all the way up from the surface, as you can see here, all the way up to around 35,000, 40,000 feet. So our atmosphere was just saturated. And these are the surface winds. I just want to point out the fact that we had some strong surface winds from 6 a.m. to midnight. And usually when the sun goes down, the surface winds begin to die down, but not on that day. Those surface winds remain rather strong, as you can see. 9 p.m., 36 mile per hour surface wind. Midnight, 21. And the low-level jet also would typically die down a little bit after the sun goes down. But on that day, the low-level jet remained rather strong out of the east-southeast. And dew point, the surface dew point, you can see it covered all of South Dakota. Dew points in the lower 70s. When we have dew points in the upper 50s and into the 60s, you can expect some flood watches, some flood warnings to be issued. But we had dew points even higher than that. Just an indication of how much moisture we had. And the dew point, this is a timeline, as you can see, from 1 a.m. On the morning of June 9th all the way to the June 10th. And you can see the dew point just maintained itself at 70 degrees for that period of time. So the moisture was just incoming, and it never quit. It never quit on that day. So this is what was happening. All right. I mean, we've seen this so many times. We get thunderstorms developing over the Black Hills. We get these feeder clouds. We get the low-level jet bringing in all that moisture. And these thunderstorms develop. They rain out. And the clouds disperse. The sun comes out. Everything is hunky-dory. So something else must have happened on June 9th that doesn't typically happen. And what happened on June 9th was, okay, let me talk. You need three things. You need the moisture. We've already talked about the moisture. You need instability to kick off these rain showers. That's simply cold air over warm air. And we had instability on that day. This is the 6 a.m., this trough right here. This is a pocket of cold air. This is 6 a.m. This is what the sounding recorded at 6 a.m. And then at 6 p.m., you can see that pocket of cold air has now moved over the Black Hills. So we have the instability. Now we also need the trigger. And trigger is basically a kick in the pants, something to get things going. And we had a surface trough. We had a little surface trough right here. Winds are to the north of that trough, or generally out of the northeast. Generally out of the southeast to the south of this surface trough, this little stationary front. And so you're getting convergence right there, and that's what the trigger was. That's what the trigger was. So we had the moisture, we had the instability, and we had the trigger on that day. But as I was trying to say earlier, but something else must have happened, because this is a typical June day. This is a very typical June day. We get moisture from the south. We get the instability, little pockets of cold air, as well as a trigger. But what happened on June 9th, 1972 to cause all of that flooding? You can see that's pretty much a stationary front. This is your typical June day. A towering cumulus, thunderstorms develop over Wyoming. 3 p.m. These thunderstorms develop, and again, we see this a lot. But what else happened? This is what happened right here. If you go aloft, this is the sounding at 6 p.m. on June 9th. These winds up here, these are known as the steering winds, and these are the winds that push these thunderstorms off the Black Hills. Typically, you'll see these things develop in the afternoon, early evening hours, and then they just slide on off into the prairies. Not on June 9th, because our steering winds, the winds that push these things off the Black Hills, were definitely on the light side. So these storms on that day remained stationary for a long period of time and produced, as you've been reading, I'm sure, 15 inches of rain in local areas over a very short period of time, over a 6-hour period of time. And the Black Hills are stationary, of course, so the winds were too light to push these things off the Black Hills, and of course the Black Hills aren't going anywhere, so we had this orographic lifting, and it just rained from the afternoon hours until shortly after midnight that evening. All right, let me back up a little bit. All right, now we're going to talk a little bit about the hydrology on that day. Melissa.
Okay, so as we look at the rainfall on that day, these are rainfall amounts in the Rapid Creek Basin. We can see that most of that rainfall fell in that short period of time. I just highlighted some areas in red. We had 2 to 8 inches there, Johnson Siding, Wild Irishman Gulch, Schroeder Road area, 10.5 inches by 10 o'clock. Here's it looking at it graphically, just seeing that all that rain fell in such a short period of time over the different areas in upstream over the eastern foothills. So as Bob said, those storms started developing about 1:30 or so, and by about 3 o'clock, you started seeing a little bit of rain there southwest of Sturgis. 4 o'clock, still only just a few storms out there. We were getting the heaviest rain over the Galena area. 5 o'clock, the storm started increasing in coverage. By this time, you were getting about 4 inches in Galena, Bear Butte Creek drainage. And then that's about when the rain started in Pactola, was about 5 o'clock. 6 o'clock, those storms started spreading. They started becoming more common over all of the eastern slopes. By this time, all that rain around the Galena area was causing a foot of water to go over the highway between Sturgis and Deadwood there in Boulder Canyon. We started getting some heavy rain up in the basin above Rapid Creek, and then also the storm started extending all the way down to the Hermosa area. By this time, there was about 3 inches of rain around Pactola. 7 o'clock, that's when the rainfall amounts really became much heavier. There was about 2 to 4 inches of rain being reported an hour upstream of most of these streams that are coming out of the hills. The first flash flood warning was issued by the Weather Service, but that was mainly for the Bear Butte Creek drainage, for that area around Galena where there was all the water going into Sturgis. In that area, and the rainfall around Piedmont, it wasn't for the Rapid City area. 7:45, you start getting flooding along Box Elder Creek and some dams that started breaking around the Nemo area. By 8 o'clock, there was a solid line of storms along the whole eastern slopes. And the Weather Service issued the flash flood warning for the Box Elder Creek Basin and the Rapid Creek Basins. And that's when the Ellsworth Air Force Base radar operator went and let the Weather Service know that there was some heavy precipitation in that Rapid Creek drainage. By 9 o'clock, all the rain had started to shift south. It was no longer raining up in that Galena, Sturgis area. And then the forecast was updated. The rain's going to continue to about the midnight time frame. By this time, there was 11.3 inches up by Sheridan Lake with 9.5 inches of rain by Nemo. All these rainfall amounts weren't relayed in real time. They were all rainfall amounts that were determined afterwards. The rain gauges were recording gauges, but there was no way to get that information right away. So this was all after the fact of what they found out. Between 9:15 and 10:15, the river gauge near Canyon Lake rose 12 feet. It also rose about 3.5 feet within 15 minutes during that time frame. So the water started really coming up. What was happening was you were getting the water coming out of Claycorn Canyon, Dark Canyon, Red Rock Canyon. The storms were moving down Rapid Creek. The storms were moving down the creek at the same time as the rain, and the storms were moving at the same speed as the water. So it was contributing to that at the same time. By Canyon Lake Dam started getting clogged with debris around 10 o'clock at night. Claycorn Canyon peaked at over 12,600 CFS, and Canyon Lake Dam eventually failed at 10:45. By 11 o'clock, it just started raining at the airport. The eastern side of town really didn't have any rain until 11 o'clock at night. Most of the rain was just on the west side of Rapid City, and it was up towards Johnson Siding all the way up to Pactola. By midnight, the flood crest reached downtown Rapid City with an estimated flow of 50,000 cubic feet per second. If we were to look at Rapid Creek today, you'd probably only have a couple hundred cubic feet per second that was flowing in Rapid Creek if you looked at it right now. And then by 5 o'clock in the morning, Rapid Creek was back at its banks. This was the overall rainfall amounts. You can see those darker colors. Those were the intense amounts. Those lighter colors that you see as you get onto the plains were much less. But amounts greater than 14 inches up there in the Rapid Creek Basin, the Box Elder Creek Basin, the Elk Creek Basin, all those basins had those extreme amount of rains. Next, we'll go on to today's technology with Susan Sanders.
So just as technology changed your lives, how you live day to day compared to 1972, it's also changed how meteorologists observe weather conditions and let you know information about what's happening. This is an image of the Ellsworth Air Force Base's weather radar in 1972, 7:30 at night. So as Melissa was talking about, when the storms had formed a pretty solid line along the eastern slopes of the Black Hills. But you can see there's not a lot of details. The images are kind of fuzzy. It doesn't give you a lot of information. And they had to make an overlay to show where the storms were, and then later on, when they took another image, then they compared those two. And that's how they determined motion. Today's Doppler radar has a lot more information because of computer power. So first of all, we can see storm intensity. This image is from Hermosa in 2007, where there was a similar flash flood, only it was just a much more isolated event, not nearly the extent of 1972. So Hermosa is in this white circle, and we can see a very strong thunderstorm just over the Hermosa area, just a little bit to the west, where another thing with computers is that we could have overlays with the streams on there. And the Doppler radar also estimates rainfall. While it may not be exact due to just variations in the atmosphere compared to the equation used to compute these, it gives forecasters an idea of where that heavy rain is falling. And so it allows us to then go look for ground truth and say, well, how much rain is it? The radar is estimating between 5 and 6 inches. Is that really what's fallen already? And so we can determine that. But also with those overlays, then it can tell us what streams that rainfall is falling in. And in this case, that heavy rain just upstream of Hermosa was falling in both the Battle Creek and Grace Coolidge Creek basins. So just like we talked about with the 1972 flood, that the rain was falling in Prairie Creek, Victoria Creek, Deer Creek, Cleghorn Canyon, all those tributaries flow into Rapid City, of course, above town, and that's why one of the reasons why there was so much water in Rapid Creek. The same way with the 3 Box Elder Creeks in the hills, that they all converge and come out by Blackhawk. So, this is a case where that heavy rain fell in those 2 streams. They came together and caused some very significant flash flooding on the south side of Hermosa. And so when we see this kind of information, then we can also, again, interrogate stream gauges. There's quite a few more, and they report in real time, which it gives us instant information. And they're all placed all over the Black Hills area. And we can see how quickly, in this case, Battle Creek came up during that flash flood in Hermosa. And another part of technology is communicating this information, what the meteorologists know and what you need to know. So we do this a lot more ways, that you can get information anytime and any place that you are. In 1972, the only way that the Weather Service had to provide warning information was a one-way phone line from the weather office at the airport to the TV and radio studios. And they would announce something, and then the reporter would copy that information and put the scroll on the TV or make the announcement on the radio. So today we have the NOAA weather radio stations. You have that receiver in your home. It works on batteries if the power is out. If you're sleeping and you don't have the radio or TV on, it'll wake you up to let you know about dangerous storms. The local media also monitors that signal, so just as you get those warnings, it has a scroll on the TV stations or interrupts radio programming to give you that information as well. And then finally, with cell phones, our warnings are sent to the wireless emergency alerts, so you get that information on your cell phones as well. So think about, how can I get warnings at any time or any place? That if you live in a place where you don't have a good cell signal, the weather radio is a good source of information. If you're not at home, your cell phone is a good source of warning information, because you'll get those alerts if you're very close to that situation, no matter where you are. If you're traveling, you don't have to worry about what county am I in. If you're close to whether it's a tornado or a flash flood, you'll get that warning information. And then we're going to wrap it up with Alexa talking about preparedness and the responders.
So real quick, I wanted to show, she talked a little bit about the stream gauges, and I see a USGS over here, the Met Warren system that we now have that was put into place in October of 1998. There's 13 gauges that measure peak flow and or precipitation at those locations, and you can see the funding partners down that help support that cost annually to make sure that those gauges are working. That gives us a vast amount of knowledge that we didn't have then. This is just a quick map that we have that shows those locations and where they're at, and I have a couple of those copies if somebody wanted one. We didn't have search and rescue back then. We do now. We now have 34 all-volunteer team members that train regularly, and they're very excited to do that, and they want to help people. So that's a huge improvement of something that we, people want to help other people. That's a natural thing, but do they have the skills and the training to do that without hurting themselves? And this team has that knowledge. Somehow I missed my slide for the water rescue team, so I'll just touch on them really quick. We didn't have a water rescue team. We do have that now, and that is, of course, very important in our area with the flood history that we have, and the fact that it's going to keep raining and the water's going to keep coming, and we just need to know how to help people when that happens and try to keep them out of the way. But Rapid City Fire Department they kind of oversee that water rescue team, but the team is made up of members from all of our response departments, and I think there's 15 members right now. But you can see in 1972, there was 71 personnel at Rapid City Fire. Now there's 142, and we have a hazmat team, and so you can see what we had then and what we have now to deal with emergencies and disasters. Pennington County Fire, while the number hasn't changed a lot, they had 500 then, they have 510 now, the amount of training that those individuals go through is significantly increased. And again, they all volunteer. My husband's a chief at North Haines, and he's gone a lot, and sometimes I grumble about it, but I know he's doing important work when he's doing his fire department stuff. I'll go back really quick. Keystone, this was Keystone, and they were, the fire department had a lot of damage from the storm, from the flooding. And they were formally recognized as a town of Keystone the day before the flood. So that it really improved their recovery piece and the funding that was available to them and the people that lived in that area. So we just found that out about a year and a half ago, and I just thought that was really ironic, maybe? I'm not sure. Rapid City Police Department had 64 responding personnel. Now we have 130. So a pretty good increase there. This car here, while it wasn't exactly the car that was here in our area, at that time, this is a car they have now. They probably had Ford Galaxies. This is a Plymouth Belvedere that they have. But these were in use in the United States at that time in 1972. The Sheriff's Office had 10 responding personnel at that time. Now they have 100 full-time. You think 10 for the size of our county, even in 1972, was like, oh, they couldn't get very far very fast. And then one of them was in the EOC talking on the phone, or talking on the radio. So that's not a lot of help. So we have a lot more help now. And of course, we don't want to forget the parkland that we have. And we want to remember why that's there and why that's protected and why we want to keep people out of that area. And it's there because people died. And I think that's so important for us to remember and never forget why that beautiful area is there and why we want to keep people out of that area. And here, 50 years later, it's easy to forget, and people come and they say, well, there's all this land here. Why can't we build something here? Well, you might be able to build something there, like a school or the Civic Center or the monument here. We don't want people sleeping in that area. Places where they are not going to know what's going to going on, or places they can't get out of quickly, hopefully, if a situation is occurring. With this technology that we have to know what's going on, that helps us get out and move faster. So what you can do is we have, she touched on, 3 of the pieces of warning. You know, make a plan, know the hazards in our area. We know that flooding is going to occur. We know that blizzards are going to occur. We know that these things happen. We might have an occasional tornado. Know what those things are and make a plan for it. We have this magnet at our booth, our table. If you want it, this is all this information. 10 basic items we recommend. You want to have a 72-hour kit in case you had to leave your home quickly or you hunker down in your home and stay there for a while. What should you go to the basement? Should you go to higher ground? What should you do? And as Susan talked on a few of the weather warning, the warning information that we can get out. So outdoor warning sirens, just a myth. They're not meant to be heard in your home. So if you can't hear them in your home, that's pretty normal. They're meant to warn people who are outdoors. So they're strategically located in places where there's schools, outdoor activities like soccer complex, you know, things like that to alert you. But the thing is with sirens, you kind of hear it and you go, I wonder what that is. And then you move on. So you need to have multiple layers of warning. And that's where, you know, if you are someplace where there's a weather radio, you have one in your home. Maybe you live in the hills and you don't get good cell service. So you're not going to get warnings on your phone like you would maybe if you were at work, you know, downtown Rapid City. The wireless emergency alerts, while those are a huge, amazing technology, if you don't have cell service, which we know in Pennington County, not everybody does, those might not work. So you need to have other layers of notification. And we know that people need to hear things more than once to take action. They need to hear it like, oh, and maybe they even need to hear it from their friends or somebody calling them. So, well, did you hear that? I did. We should check that out from trusted sources. Find out what's going on so you can make a decision. Our public warning messages are what you can sign up for. You can get text. You could get a fax if you wanted, even an email. You can get it however you want to get the message. And those are things that are going to be sent out that are life-saving, you know, things that might kill you kind of messages. And then we do have some different training options that we have. Community Emergency Response Team, Stop the Bleed. These are all things that anybody in the community can take. It's not something where we're going to page you out to go to a scene or an incident. But if you say we're here in this room and somebody has a medical emergency or they trip and fall and they're bleeding or some, you know, some kind of, I don't want to say terrorist activity, but something happens, you will have some skills and training that you could help somebody else. And this is a 7-week class that we offer in the spring and the fall, and it's free. And just I want to share, preparedness is a shared responsibility. It takes all of us. So you take care of yourself, you take care of your family, and you learn what you can do to help others, and then we'll all be in a better spot.
Thank you so much. Does anyone have one quick question before we switch out our groups and let our next group of panelists come in? Yeah, go ahead.
How much effect did the cloud seeding that was going on the day of the flood affect what happened?
I was a graduate student, and I was involved in that experiment. It was known as Cloud Catcher. And they seeded clouds on that day. They used salt. There's two ways of seeding, salt or silver iodide. Silver iodide produces a dynamic effect, supposedly produce a dynamic effect to the clouds, make the clouds grow taller, increase the updrafts in the clouds, bring in more moisture in the clouds. That's silver iodide. Silver iodide was not seeded on that day. They use salt, and all salt does, it doesn't increase the amount of moisture in a cloud. It just changes the cloud drop distribution, causes the cloud to seed or to rain a little bit earlier. At least that's in theory. That's what they were trying to do. So, and they were seeding clouds, I believe, about 3 or 4 in the afternoon over northwest of Sturgis, and they followed that cloud, and that cloud eventually just dissipated. And then near Fairburn, which is just east of Hot Springs, they seeded some clouds there, and they followed around 6, I believe, 5 o'clock, 6, and they seeded some clouds again with salt. And they followed that cloud as it moved closer to the Black Hills, and that one just pretty much rained out before it reached the Black Hills. And there's a lot of controversy about that, and there's still controversy about that even today. But they brought in 3 scientists to review the data and try to determine whether or not seeding had an impact on the June 9th flood, and they determined it did not. And with the type of seeding, once you're done seeding with salt, basically the increase that you would expect is come to an end rather quickly. And again, it's not with silver iodide. They were looking for it's a different method of. Did that answer your question?
So I think that's what we have today. We'll let everyone switch out. Susan, you have a final.
And both the Emergency Management Office and the Weather Service have tables downstairs. So we have information that you can pick up, but we'll also be down there later on after all these programs, and you can ask your question if you didn't have a chance now. You can talk to us later.
Thank you guys so much for coming. We appreciate it.